Hello everyone and welcome back to Technically Unsure, where I'm not really sure what I am doing technically.
Going on an adventure!
It's been a couple back-to-back videos that I get to talk about bootkits and BIOS and UEFI security. We did a video on core boot and I showed you guys a protectly device that is expensive because a lot of people spend a lot of time porting core boot to that particular device. So that's the cost of R&D.
Cost of doing business.
And I did another separate video where I showed you guys how you can dump a firmware, dump the BIOS, dump the UEFI, and then how to extract the files and PE files in it, and then analyze it and see if there is anything abnormal going in there. Just a coincidence. There is a news that just came out that's on the news today, and yeah, today it just came out today, and this is basically a UEFI bootkit targeting Linux kernels and Linux computers and Linux machines, so people who use Linux. So in the past we have seen some that UEFI bootkits that were modifying the NT Windows and NT loader and Windows bootloading process and trying to do stuff in there. This one is, I believe this is the first one that is targeting specifically Linux users. The good news is, this seems like the people behind it were just trying something. Like it's like a proof of concept bootkit, sorry. But still, it is very, very interesting. I just wanted to take a look at it and take you along with me during this reverse engineering journey. I haven't started anything, so we're gonna do it together. Let me start sharing my screen. Okay, so this is the news that I saw, okay? That cybersecurity researchers found a bootkit, and apparently somebody uploaded it to VirusTotal, and that's how ESET researchers got access to it, okay? And there is some diagrams on how this is supposedly works. And there are multiple components. We don't care about the other components. I just want to take a very quick look at the UEFI part of it and show you guys how you can do the same thing, not just for this bootkit thing, but like for any other similar boards and computers or UEFI images, BIOS images that you get. The extraction part and how you can get a BIOS dump and then be able to extract the PE files like this one, the bootkit one, that's a different video. I showed you guys in my, how to analyze UEFI and BIOS image. If you haven't seen, go check that one out. But if you have seen that, so you know how to extract these PE images. So anyway, I was reading through it and I got my hands on it. So my Ghidra is here and I have my bootkit. So these components, I'm gonna keep it like that. This is the bootkit, and that's the hash that's mentioned in the news and everywhere. So I have access, I got this file. So what we are going to do is I am going to just drag and drop that in here. As you can see, it's PE file. And we did this in the other video where I was showing you guys how you can, extract and reverse engineer everything in Ghidra. And yeah, so go check that out. So anyway, let the Ghidra analyze this, and I just want to take a look at a couple of things, okay, and just see how it all. Okay, first of all, as you can see, there is a lot of plain text stuff going on in there. So we are going to take a look at the strings. So let's take a look at it very quickly first in the strings. Okay, we see some ASCII art over here. Yeah, BootKitty. That's where the name is. As you can see, the developer behind is not trying to be subtle, right? There is like a BootKitty right there, and there's ASCII art, BootKitty's bootkit. And it says Lee Junho Seo Hyun Yu. The name sounds Korean, I think. I'm not attributing anything to anyone, all right? I'm just saying the names, Jeong, Jinho, and all these stuff, these names, I mean, anyone can make up any names, okay? I'm just saying sounds Korean, and it doesn't mean some, North Korea, South Korea, it doesn't matter. I'm not saying anything. I'm just saying sounds like that. Very interesting string right here. I can see here, LD preload. That's a common trick you can do in many cases, many exploits in Linux. If you're familiar, you know that when using LD preload, basically your SO library will be loaded before the binary being loaded. So it is already, I see that it is trying to inject some, and it's, yeah, there you go. It's even called injector. So it's trying to inject a library to init process. BootKitty's Bootkit also here. And I see that EFI Ubuntu, this is the Grub from Grub, the Linux kernel, it's secure boot, okay. And okay, by the way, there is a project path. So it is the project's BootKitty Linux EDK2. Oh, by the way, EDK2 is basically UEFI development kit. So it's E development kit, so UEFI development kit. That's the EDK2. You can get it so you can develop BIOS and UEFI code with it, and that's where these guys were doing. So made by these people. I don't know if they are the ones. I just noticed there is made by and there's special thanks to. Okay, anyway, let's keep going. If we see anything interesting, again, the same path. This is the path that they developed, compiled the code from, most likely. Again, just remember, all these things are fakeable, okay? So the names, anyone can write anything in there. The project's path, you can make stuff up. You know, maybe you can even compile it in Linux and just put these strings in there. I'm just saying, you know, these are just what is detected and seen during reverse engineering. That's what I'm seeing. And modules are there, same path, and these are the generic stuff, and the path and other generic stuff. Shim, okay, so this is rhboot shim. Let's take a look at that one. Let's go here, rhboot shim GitHub. Yeah, so this is UEFI shim loader. It just basically, I'm sure they are using some codes from it. Is a trivial EFI application. When executed, it attempts to open and execute another application. So it's they are probably using load image, start image, you know, from this GitHub project to load other binaries. So I don't know where they're using it. I'm just saying they are using it. It's referenced in there. I'm assuming and guessing that they are using it. So we'll see. There's not much else going on in here in the strings. We're gonna come back to it. I just want to know like where secure boot is used, where the stuff LD preload is used, but we're gonna come back to that. Before that, let's see in the functions entry point. Yeah. Okay, so let's close this. In the entry point, let's take a look at it. So it starts with bootkit. Oh, by the way, yeah, this is a great candidate to show you some black magic. So let's take a look at it first. So, okay, yeah, here is the secure boot, right? So you see the code really doesn't make any sense right now. I'm sure there are a lot of things that are referencing EFI stuff, but we are not seeing it because we haven't processed it. So there is one great plugin for analyzing this type of UEFI firmware that you can install in your Ghidra, and then you can come here and search UEFI, and UEFI helper will be there, and then we are going to execute it. Let's wait for it to do its magic. It will take a bit. Okay. Oh, okay, it's done. Okay, so now if you take a look at, there you go. You see that? Locate protocol EFI high database protocol GUID. So it will add the GUIDs and other things that is related to, you see how many GUIDs it detected, it added it. So it will make code, decompiled code will make more sense to you when you're reading it. So if you go back to where it was, let's see what it was. So if we go back to the, where did it go? The secure boot thing. Oh, here we go. Okay, you see? Runtime services, get variable secure boot. So it means right here in the code, it is checking if secure boot is enabled or disabled. If it is enabled, it gets into this function. And what it does is boot services locate protocol EFI security to services. So this one, let's select this and let's Google it. Okay, not much. I mean, there is the GUID is there. We already coded that. So let's try this one. Okay, I'm gonna remove the GUID and search again, but let's see. Okay, not much going on. EFI security arch protocol. Okay, so this is okay. Protocol boot services. Okay, so this one is, it's actually, this is how it is displayed in here in GUID. But if we go here, it's actually the definition in the file is like this: EFI security arch protocol, like this. There you go. So EFI is all capital, but yes. So this is the definition of what we are looking for. Where did it go? I'm not going to type it. Let's copy that. Let's go back here, search. Okay. So this is EFI security architecture protocol policy. That's a policy action on image invocation and other security controls on DXC core to security driver. So it is actually being used. The parameters, one of the parameters that you pass to it is file authentication state. The service is called upon fault with respect to authentication of a section of the file. So I think when the secure boot is enabled, remember this is getting there, this function is getting called when secure boot is enabled. So what they are doing is, look at here. So they are setting some variable to some other variable and setting that variable to some other variable. Looks like swapping addresses, and it could be basically a hook, function hook. So overriding something with another function. So these are two separate function addresses. So I think they are storing the original function address in there and then setting the value to new address. So let's take a look at both of these functions. Let me copy this and then go to that address. Okay, so this is a function that is doing some checks and then returning this. Not much going on in here. Let's go back. What was the other address? It's this one. Let's go to that address. Okay. So this is an address, a placeholder. This can be set during runtime to some other value. So let's do a reference check. Okay, so here they are writing to it. Let's take a look at it. Yeah, that's where we were here. Okay, EFI security protocol architecture. They are writing to that address value of this. Yeah, okay, so they are storing the original address of that function. So they are hooking this function. So they're storing the value of that address into that location, okay? And then what else is there? Here is just calling that function. So this is calling the hooked function. This is calling the original hooked function. And when they are overriding, okay, so here, okay, so this is a function that is not really defined. It's undefined function. So it means it's not really in there. So what they are doing is locate protocol, EFI security, that thing, and then EFI security protocol, if this, and then setting the value, return eval. evar1 is set in here and there. So there are more and more. So let's see what this function is doing. Okay, so that's code and return. Nothing here. Well, let's go back there. And okay, so let's keep going. Let's keep going. So it seems like, yeah, it seems like here is just setting up the hook. This is, I think this is where they are overriding maybe. Let's see what is happening here. Okay, so this looks like a function. Let me, yeah, this is the whole function. Let me disassemble it. Okay, so yeah, this is a function. Okay, so boot services, EFI simplify system protocol. Okay, I think I got it. So here it is always setting the value in that boot check thing, this function, right? This is file authentication state. It is always seems like returning 0, and EFI success should be 0, I think. Let's see, EFI success is value is 0. Okay, so I think it is returning success for every single file check. So it's giving thumbs up. So the EFI security services where it is trying to do this will always get the result as a true, as a success, and it will just move on. I'm just thinking and guessing. So this looks like it's a code that is triggered when the boot secure boot is enabled. Okay, so let's keep going. Let's go back to where we were. We were okay. Secure boot. Where are we here? Let's go back to module entry. Okay, so I think it's trying to bypass basically secure boot's checks and all that stuff, and then get it to just load whatever it is supposed to load. Here I see more stuff. This seems like if I loaded images protocol. This could be from the other shim project that we were seeing on the GitHub. That is trying to basically load other modules. And start image, yeah, you see there is the start image and load image. So this part could be really, yeah, here you go, load image and start image. Okay, could be the part that it is using to load an image, but what it is trying to load, let's take a look at it. Okay, remember this EFI thing? And it is right around the secure boot code. Let's see if this one is related to that. So it is only referenced in one place, and this is the place. Yeah, okay, so we went over it. We didn't see it, but it was right here, okay? This is the file, this is the function, okay? It's right here. It is basically here. It is trying to load this grub file. So where we were seeing in the main function. Let me rename this function. So we are going to call it EFI loader function. Okay, so now let's go back and see where we were. Okay, so we were in the main one, right? Where were we? Yeah. So BootKitty's Bootkit, developed is misspelled by Black Cat, and then it is calling that function that we were at, which is basically loads the original path that is hard-coded. So it is there is a hard-coded path for the grub's path, and it is trying to load it, which is right here, EFI loader function, okay? And this code could be taken from this project. So far, that's where we are, okay? So it bypasses secure boot, and it calls to load the hard-coded EFI path in a grub path, okay, to load the grub. And let's go back to define strings. That seems like it's easier to trace it this way. I wanted to know where this is getting called. So what is going on in here? So let's take a look at the references to this in here. Okay. So in here, they are doing the LD preload replacing thing. So, oh, these are string, by the way. This looks like a string. So if we hover mouse over it, yeah, BOB1. So it's in a, you have to reverse it. BOB1 and then 3 is over it. And also this one is BOB1 and then 3. So it's basically doing BOB1 3. And then what is it doing though? This is Unicode. I don't know what that is. I don't know what that one is. These are probably function addresses. What is this one now? This is also not really PDL. Other. Oh yeah, so this is LD preloaded. Okay, so this is the string that we are seeing here. LD underline preload equals OPT injector.so and then init. So it's probably replacing /init with this and adding in LD preload in there. That's what it is doing. So, but let's when this function is getting called, let's take a look at that. Okay, so these two are in the same function. So this is same function referencing it, which is this function, and that one is referenced. Let me rename this to preload injection. Okay, so this is where the preload injection is happening, but yeah, let's keep going. Let's see where this one is actually getting called. Preload injection is here, referencing here, and it is in this variable that is used in here and then getting called to this function. So we're gonna see that, but what is this function, by the way? Okay, but I want to know where this function is getting called. That this function is calling the LD, preload injection code. So let's see. It's getting called in here. This one is doing stuff in there. These are a bunch of function addresses, by the way. It looks like that. So these are probably, again, more and more hooks. So it looks like it is hooking more functions. Let's see. Yeah, let's go back to where we saw that string. 1 second. Let's go back to here. We can already kind of see what they are doing. So it's loading the EFI Grub file with that shim code and start image and load image, whatever. What was it? Sorry, with the load image and start image. Yeah. So with those, because secure boot is enabled, the binary is not signed with appropriate key, for instance. Okay, you see that? You see that? If you read it, it's already there. If these fail, that could be the reason, right? So secure boot is checking the file. Maybe if there is a secure boot and your file is not signed, it's not going to be loaded. So with the secure boot bypass thing that they had in here in this EFI, they're getting rid of that check. So this is very, very complicated stuff that these guys are doing. Even though it's proof of concept, but you can see they know what they're doing. And this is obviously looks like a security researcher, I think, doing this, or they are trying to do some tests because it's bootkit and rootkit is all over the place, and they have banners and all that. Even the file is bootkit, but I don't know. Maybe this is the version 1. Then they might start to get more malicious. But yeah, we'll see. So let's see when. Let's go back to the function that this one was called. Yeah, preload injection. So in here, I want to know what's happening in here. So they are calling a bunch of functions in there. Yeah, I don't know what exactly is happening in here, but I'm gonna be honest. If you're trying to analyze a UEFI firmware and anywhere around it you see LD preload in UEFI, that should raise the alarm bells right away. There is no reason whatsoever for a UEFI firmware, for a BIOS image, for BIOS code to have anything to do with LD preload and secure boot checks like that and trying to bypass it. So you get the idea. So this needs a lot more time to investigate and analyze. I'm not getting anywhere right now with this and what it is trying to do in here. There are some references to it, but I don't know where this is getting called. It needs some investigation. I have to spend some more time on it, not like this on the live camera, but I'm just trying to show you guys what you can find. But there is also in the original news story, there is a graph in here, so it tells you UEFI firmware. It's a low quality somehow, but anyway, UEFI firmware shim64 EFI. So that's the file we were looking at, right? So here, where were we? Oh no, so not, it wasn't shim 64 EFI. No, that's different. Sorry. So I can't read what's going on here. Yeah, that's not okay. So trusted image and then grubs x64.efi. This is the file that we are looking at, and then it loads it and patches. Okay, so it is patching a couple of things. My god, I can't read it. Start image and all that stuff. Okay, so that's a VM Linux, not Linux, VM Linux. So with ending with Z, that's compressed Windows Linux kernel. So SZSTD decompress. Okay, so they are hooking this and then overriding a bunch of stuff, and then finally init load or LD preload. That's what we saw, opt injector.so/init. I haven't gotten so far with this, I get it, but imagine if this was in a motherboard that you purchased, right? So I know this makes a lot of clear text stuff in plain text, and it is showing what it is doing, but you can't hide it so much. So this is the way that you can analyze a UEFI firmware file. You basically extract all the file, like with what I showed you in the other video. You get a bunch of PE files like this one. It looks like a Windows file. It is actually just exactly like a Windows binary file because it's a PE file. And you can see the strings right here, MZ and PE, right? It is exactly like any Windows binary. So you drag and drop this into Ghidra, and the plugin that I had was basically uefitools GitHub for Ghidra. Yeah, it's this one, Ghidra firmware utils. Okay, so it is from Alex James, and this is very, very helpful. So you just basically download this zip file and install it as a plugin. Once you do that, then you will be able to see that string in the script manager. You just have to search UEFI. This UEFI helper will come and you will run it. So it will help you resolve a lot of these GUIDs. So the code will make more sense to you. And as you are investigating through the BIOS code, if you see something that shouldn't really be there in a BIOS, then you can get suspicious and start investigating. But yeah, this is interesting because there's been like multiple videos in back to back. I'm reviewing a Chinese motherboard. I'm talking about BIOS security. Then I'm getting the Protectly, device, and I'm talking about BIOS security. The news just came in today as I'm recording, November 27th. This signifies that importance of security in BIOS. I wish core boot people best luck, but it's not really easy to port core boot to every single motherboard that you're getting. So it is a challenge. It is a challenge to have a motherboard that is free of the codes you potentially might not want. It's you kind of just trust the vendors. You have to, and also don't get me started with Intel ME. That even if it is not there, or the code that starts the processor, if it's not there, it's not even going to work. So yeah, it's a very interesting times that this came out. And I just want the other thing that hit me, because it talks about Black Cat and all that stuff and ALV ransomware. I don't think these two are related, mainly because these guys are ransomware gang, and I believe these guys are Russian, and I believe these guys are usually use Rust. Almost exclusively everything they have developed is in Rust. So this is a bootkit written in C++, and it's also retargeting bootkit, and the names in the beginning, I know that can be fake, but I don't think the people behind this is relevant to this group. But just this is something very interesting. Let me take a look at it a little bit more. Maybe I figure something more. Otherwise, I'm gonna end the video. Give me a couple of minutes. Okay, so from what I gather from the bootkit code, there is no code in the bootloader in the bootkit that will write and create that injector file. It seems like this bootkit, the BIOS bootkit, still kind of relies on some user level file system access. What I mean by that is there is still some user mode component that needs to be there in order for this to function. If there is a function that that this bootkit actually drops that SO file, this is the one I'm talking about, right? So this file here, the injector. From what I gather, from what I see in this file, it's not the one that's dropping that injector.so. Seems like it's expecting that opt injector.so to be there. This code, this bootkit, is only basically making changes to Linus, the compressed Linux image. Just make changes to the init. So init is the first binary that is executed after Windows, the Linux kernel is starting to boot. So it just adds the LD preload. So the init will preload the injector library, injector.so, but that injector.so is expected to be there. So, you know, what I mean by that is if you have a BIOS that is shipped to you and you have this bootkit in the BIOS, if in the motherboard, if that bootkit is in the BIOS of that motherboard, but if you install a fresh operating system and that opt file and other files are not there where it is expecting it, it's not really going to do much. It relies on the Windows part, I mean in the operating system, in Linux or Windows part, whatever, to have those files in there so it can basically get executed. But I might be wrong. That's what I'm seeing. From what I gather, it's not creating that file from the bootkit side. So it's still, I'm not trying to downplay, it is still something. It can, eventually someone can take time and complete this. And from what we can see, this seems like a proof of concept. It is very, very complicated process. It's not really easy to develop a fully, you know, BIOS, a rootkit, a bootkit that is only, you know, staying in the BIOS, and then from BIOS it can get into your operating system and do all sorts of stuff purely from BIOS. It is doable. It's a lot more work. Okay. Even this, I'm sure, is a lot of work. You know, it's not, it's basically bypassing secure boot and the signature checks and all that stuff, and hooking a lot of functions and waiting for Linux kernel, then injecting this into, you know, init command and making it load another library, injector.so. So this is just to give you an idea how you can analyze a firmware, a BIOS image, and extract these type of secrets if there are any in there. It's not too, you know, it's not somewhere that you can really hide too much, because at the end of the day, when you buy a board, you can dump the firmware, extract all the EFI files in it, and then load them in Ghidra, use that extension that I showed you, and look inside it and see if there is anything abnormal and suspicious going on in there. And if there is, you can opt out to just, you know, get rid of that board. Or, as I showed you in the video, just use a device that core boot is loaded and supported on it, which is like devices like Protectly is selling, or like other vendors too. It's not I just showed you one example. There's like System 76 doing this and many other companies. So you can see the compatibility list in the core boot. So anyway, I don't want to make this video any longer. I showed you a bit about this bootkit. Sorry, I'm not used to saying bootkit. Rootkit is the most common one that you see. Bootkit is not something you encounter every day. So yeah, thanks for watching. Please let me know what you think down below. If you have any questions, I will try to answer it. And I will see you in the next video. Thank you. Bye for now.